How was artificial intelligence made? The machines that exist in our world today show signs of being as intelligent as humans. This idea of a machine being able to display intelligence similar to that of ours is exactly what artificial intelligence is about. Today, it exists as an entire branch of computer science, and its practical applications are so widely used that it has become all but essential to our lives, especially with the recent AI boom going on. So today, we're going to dive back in time and explore the history of computer science to discover just how AI was made. Historical background. The idea of autonomous machines that could act on their own has been part of humanity for a long time now. In Jewish folklore, there was the idea of the golem, a creature animated from clay or mud. Similarly, in Greek mythology, the god Hephaestus crafted automatons to assist him with his work, while early Greek and Chinese texts also contemplate the idea of creating automata or self-moving machines capable of imitating human actions. These myths and texts show just how far back the desire to imitate humans through mechanical means goes. The foundations of AI were greatly influenced by the pioneering work of Alan Turing during the early computing era. Turing's conceptualization of the universal Turing machine essentially set the bounds for modern computing by providing a theoretical framework for the limits of algorithmic computation. This was a massive step towards understanding what machines can be capable of and what not. Turing's insights, coupled with the exploration of machine intelligence in his seminal paper, Computing Machinery and Intelligence, helped in shaping the trajectory of AI research and development. Then there was the Turing test, or the imitation game, Alan Turing's most major contribution to the field of AI in 1950. The test proposed a pragmatic approach to assess a machine's ability to exhibit intelligent behavior indistinguishable from that of a human. If the evaluator in the test was unable to distinguish between the human and the machine in the test, the machine would pass the test. The Turing test has since become a benchmark, sparking discussions on the nature of consciousness, self-awareness, and the elusive quest to create machines that could seamlessly mimic the cognitive abilities of humans. The birth of AI. The birth of artificial intelligence as a field proper came in 1956 in the form of Dartmouth Conference. Conceived by John McCarthy, who is often referred to as the father of AI, alongside Marvin Minsky, Alan Newell, and Herbert Simon, this historic gathering marked the establishment of AI as a distinct discipline within computer science. The conference aimed to explore the potential of creating machines that could replicate human intelligence, setting the stage for decades of innovation and exploration in the field. Following the Dartmouth Conference, the first AI programs emerged as early attempts to demonstrate machine intelligence. The logic theorist, developed by Newell and Simon, made headlines by proving mathematical theorems using symbolic reasoning. This was a groundbreaking achievement that really showcased the potential of machines to perform tasks traditionally reserved for human intellect. The subsequent general problem solver, another creation by Newell and Simon, demonstrated a more generalized problem-solving approach, marking further progress in mechanizing intelligent thought processes. Although the success immediately after the Dartmouth Conference was exciting, limitations soon arose as researchers struggled to apply their work to real-world problems. The initial optimism may have led to some unrealistic expectations of what AI could be capable of at the time, which culminated in a bit of a downturn for the field. The AI Winter. This downturn is known as the AI Winter, set during the 1970s and 80s. During this era, the AI community faced significant challenges because of overambitious promises and unrealized expectations for the field. This led to a huge decline in the funding of AI research, as the public and investors had anticipated rapid advancements in AI, leading to disappointment when progress did not meet those projections. The AI Winter led to a reassessment of research priorities and methodologies. The early emphasis on rule-based systems and symbolic reasoning faced criticisms for its limitations in handling real-world complexity. Researchers began exploring alternative approaches, such as expert systems and heuristic methods. This shift in focus helped mature the field, acknowledging the need for more nuanced and practical solutions to the challenges posed by AI applications. Expert systems emerged as a prominent AI approach during the AI Winter. These systems aim to capture and replicate the expertise of human specialists in specific domains. By codifying human knowledge into rule-based systems, expert systems sought to provide intelligent decision-making capabilities in fields like medicine, finance, and engineering. Successful examples include Mycin, designed for medical diagnosis, and Dendril, focused on chemical analysis. However, the limitations of expert systems, particularly in dealing with uncertainties and adapting to dynamic environments, soon became evident. Human expertise was, as it turns out, not so simple to replicate through rule-based systems. Rise of machine learning. Eventually, the AI winter came to pass, and with its end came another shift in focus, this time towards a more data-centric approach, leading to the rise of machine learning. This is a subfield of artificial intelligence that includes developing algorithms and models that are capable of learning from data and making predictions or decisions. The key concepts include training models on datasets, generalization, and iteratively improving the model's performance based on feedback. Early machine learning algorithms, such as linear regression and decision trees, laid the foundation for more sophisticated techniques. The 1980s and 1990s witnessed the development of neural networks and the backpropagation algorithm, paving the way for the resurgence of interest in machine learning. These advancements in algorithms were critical for handling complex patterns and relationships within data. Resurgence of AI. Neural networks in particular were of great importance for machine learning, as the technique was heavily inspired by the structure and functioning of the neurons within the human brain. They became a focal point in the resurgence of AI. Connectionism, as a paradigm in AI, emphasizes the interconnectedness of simple processing units, neurons, to perform complex tasks. This departure from rule-based systems allowed for more flexible and adaptive learning. Researchers such as Geoffrey Hinton, a pioneer in neural network research, played a pivotal role in advancing connectionist approaches. Hinton's work on deep learning, especially the development of deep neural networks, brought about transformative changes in the field. The layered architecture of deep neural networks enabled the extraction of hierarchical features from data, leading to breakthroughs in the field. Deep learning's success manifested prominently in various applications. This is where the applications of AI in real life truly began to take shape, as researchers realized the potential of machine learning in tasks like image recognition, natural language processing, and more. Image and speech recognition systems reached unprecedented accuracy levels, making them integral components in technologies like facial recognition and virtual assistants. Natural language processing, or NLP, also experienced revolutionary improvements, leading to the development of conversational AI, chatbots, and language translation services. Other major factors that contributed to the AI comeback in the late 20th and early 21st centuries include a massive increase in computing power driven by the never-ending advancements in hardware, helping to overcome a great limitation of AI research up to this point. Another major player was the role of big data, which became a crucial asset in AI development. The availability of vast amounts of diverse and labeled data became instrumental in training machine learning models. Big data allowed AI systems to discern intricate patterns, enhancing their ability to perform tasks such as image recognition, language translation, and autonomous decision-making. This combination of increased processing power and large datasets was able to provide the necessary resources to train complex and intelligent AI models. Future directions. Today, ongoing AI research is marked by several key trends. Techniques like transfer learning leverage existing knowledge from one AI task to help with another. Reinforcement learning to teach AI models how to learn from their mistakes and get better and better at a task. And generative models have revolutionized content creation with the ability to produce realistic images, videos, and text. There are a few freshly emerging techniques too that are poised to shape the future of AI. Quantum computing holds promise for solving complex AI problems, while neuromorphic computing aims to further mimic the structure and function of the human brain. These technologies have the potential to significantly enhance the capabilities of AI systems, opening up new frontiers in problem-solving and innovation. Moving forward, ethical considerations will remain at the forefront of discussions on the future of AI. As AI applications become more integrated into society, ongoing conversations focus on establishing ethical frameworks. Transparent decision-making, accountability, and a commitment to fairness are key principles guiding the ethical development and deployment of AI technologies. At the end of the day, the future of AI hinges on responsible development practices. Stakeholders, including researchers, policymakers, and industry leaders, are actively engaged in defining ethical guidelines. Emphasizing the responsible use of AI is critical to maintaining trust and ensuring the technology's positive impact on society. It's also crucial to avoid a Terminator 2 situation. So, that was the story of how the idea of artificial intelligence went from myths and legends about automatons to a crucial part of our everyday lives that power some of the most intelligent and human-like technologies in the world today, like ChatGPT and Bard. And if the past few years alone are anything to go by, there's most likely no limit to just how far the field can go and what it can achieve. Hope you learned something from this video. Thanks for watching.